this video, I'm going to demonstrate conducting an exploratory factor analysis in SPSS. I'm not going to discuss theory in this video, but I'm going to show you how to do it. So if you would like to follow along, the link to this data set will be down in the show notes, so you can open that up and follow along. Well, in order to do this, I'm going to show you first this data set's got 20 fictional scale items, Likert type items. We're going to go to Analyze, and to get to exploratory factor analysis, we need to come down to dimension reduction and click on Factor. Okay, that's where we find it. Click on Factor. Now what I'm going to do first is just collect my items. I'm going to select those 20 and pop them over in this Variables tab here. Make sure I've got the correct ones. And then I have these various options. So let's look at what we have here. Descriptives here, you can look at the descriptive statistics for my variables. I can look at the correlation matrix that's going to be used if I wish to. Under extraction, I have these options. The first thing right here, method, is important. Principal components analysis is a little bit different than actual exploratory factor analysis. And most theorists nowadays prefer maximum likelihood for exploratory factor analysis for most cases. There are these various other options if you want to do them, and they work the same way. But I'm going to go ahead and click on maximum likelihood. In most cases, that's what I'd recommend you use. And I'm going to look at the scree plot, which helps me understand the relationship of the eigenvalues, so I know how many to extract. Now, I have these various rules for deciding how to extract. One of the defaults a lot of people use is number of eigenvalues greater than 1. Often that will extract a lot more factors than are really meaningful, so I don't recommend using that as a final solution. Sometimes that's nice to look at as a first pass to see what's going on in company with the scree plot that'll come out, so I know whether maybe I want to go back and revise it later. I'll just put that for now. We'll hit continue. And then rotation. We need to rotate. We have these various options here, some of which are orthogonal and some are oblique. Varimax, for example, is a very commonly used orthogonal rotation, which is essentially when I want my factors that I extracted to be quite independent of each other, extracted in a way that they're not as correlated with each other. While oblique assumes that they can be correlated with each other, which is often more reasonable if you're looking at human traits. And I'm going to go ahead and do that. I often like to use Promax for my oblique, but there's these various options here for you. I wouldn't worry about these things for right now. Okay, go ahead and hit continue. The scores option allows you to create factor scores and save it as another variable. Okay, so if you do that, you would just click on it, choose which of these options. I'm not going to go into theory. And it would save as a new variable. I'm not going to do that in this case. And the options just have to do with missing values, okay, excluding listwise. I don't have missing values in these variables, but a listwise would exclude any rows for which one of the responses for these scale variables is missing. Well, pairwise, as it calculates each pair of correlations in order to conduct the exploratory factor analysis, excludes just, it retains, I guess I should say, all data that could be used to create the correlation for that pair, okay? And this does a simple imputation with a mean. I'm just going to leave that there. And let's go ahead and click OK to look at our initial results. I always consider these initial results because we may not be set on the number of factors yet. You see that because I asked it for descriptive statistics, I do get those here for my means and my standard deviations for all 20 variables, as well as the sample size for each of those. You see I have no missing data, that all have the same amount. Okay, and what we're going to do here is I'm going to focus on the particular output that is most often used and most often meaningful. in my first step, when I'm trying to decide how many factors I have, I really want to look at these initial eigenvalues. You see that I have 5 of them that are greater than 1. And so my default is going to be here to use 5 eigenvalues. However, if I scroll down, because I asked it for the scree plot option, I can look at this. Now, one rule is, or guideline, is you want to retain as many factors as you get points here before the point at which this becomes more or less a straight line. And you can see starting at the 3rd point, this is more or less a straight line. So I would, based on this rule or guideline, use just the first 2 factors, just use 2 factors instead of 5. Now, in the end, my recommendation is go on what gives you a meaningful interpretation, but we're going to go back and do this with just 2 in a minute. So here you see I have my factor. This is my rotated factor matrix, and I have a pattern matrix. Okay, which if you want to know are things rotated or not, you just have to look at the the notes on the bottom. You can see this is rotated. It has all of my factor loadings rotated. There is a way to have it screen out the factor loadings that are below any value, so this is easier for your eye to look at and process. For example, you might say, I don't want to look at if it has a value, a factor loading less than 0.1, I don't want to view it. Or maybe 0.3. Often one guideline is that about 0.32 is a threshold, good threshold for loadings that are important. So sometimes I screen out less than about 0.3, sometimes 0.2, depends how what I'm trying to do. And it's generally the pattern matrix is the main thing we're going to look at here. And this shows us how strongly these factors correlate. Remember, I allowed them to correlate a little more strongly. They'll always correlate a little bit, even if you use an orthogonal correlation, but in this case, they're allowed to correlate as strongly as needed to get the best fit here. Okay, so I'm going to go back now and I'm going to revise this to just use 2 factors. Come up to dimension reduction factor again. There's all the information before was in here. And if we go to options here, this is where it allows me to suppress what it views below some value. Okay, so I'm going to put in here 0.3, which is a little more aggressive, I guess you could say. If some, it might be if there's one that's 0.29, I won't be seeing that, which is something. It's not real important, but a little more important than a 0.03 or something. But I'm going to go ahead and put it at 0.3 to clean it up quite a bit in this case. Click on Continue. Click on OK. And it'll give me the same results as before, except in this particular case, down here, I'm going to find that there's only 2 that occurred, and you can see, you'll see these come below. Oh, I forgot to put the 2 on there. That's why I'm not seeing it. So let's just go right back up there to dimension reduction, and it's under extraction. I'm going to change it to just a fixed number of 2. Okay, so I've got just 2 factors to extract this time, and it'll give me the results that way, and that looks better. So then I still have the same information in general, and we start seeing a difference when we get here, just 2 factors. And I want to come down to my rotated pattern matrix. This is where I have the loadings that I generally would report and interpret. And you see it's actually turned out quite clean here, where every variable loads on one of the 2 factors and doesn't cross-load. There's no cross-loadings, meaning there's no items that have large loadings on 2 factors. Okay, so I do have some that are negative. So that is my basic pattern matrix there that I would interpret the loadings on, and came out quite clean in that particular case. So that's a basic overview of how to do an EFA in SPSS.